Okay, people are still joining in, but let me slowly start. So welcome everyone to the virtual seminar in economic theory. Today we are happy to have Bart Harstad from University of Oslo, who will present the paper, The Conservation Multiplier. We expect also a guest panelist, Tim Besley, but he might be late. The format is a 60-minute presentation, and it will be followed by 15 minutes of question and answer session later. During the talk, please post comments and questions in the question and answer section on Zoom. We may select some clarifying questions to ask during the talk, but we will postpone the rest of those questions to the end, and we will not reply by typing. Also, this talk is recorded, so that should just, you know. Next week, we will have Aislinn Born from Penn giving a presentation misrepresenting social outcomes and information campaigns. Okay, Bart, the floor is yours.
Thank you. So should I, first I want to say thank you so much for the invitation. It's great to present for you, even though without the hassle of traveling, even though it would be nice to see you all in person, of course. So should I just start, or should I wait for...
No,
I will start. Good. So, okay, so this is a very recent project, which I have not presented very much. The primary motivation is based on deforestation rates that we see throughout the world, in particular in Brazil. So deforestation in Brazil has really accelerated the last few years. So only from 2018 to 2019, it increased by 27%, and it was already very high in 2018. In the protected areas within Brazil, it has increased almost doubled in that very short time. So this is a problem because deforestation in the tropics has, over time, contributed to 30% of the carbon dioxide emissions we have. And every year, it adds to between 10 and 20% of the greenhouse gas emissions. And in addition to that, it's, of course, a primary loss. It leads to biodiversity loss and the losses of the homes of the indigenous people. So these are leading to huge negative externalities on the world. Even though estimates suggest that we can cut in half the deforestation at 1% approximately of that externality. So the benefit-cost ratio here is really enormous. So there are many reasons for why we see deforestation, but everyone seems to agree that the governmental policies is very important. So that's what I will focus on today. And in a very recent working paper by Robin Burgess and several co-authors, they analyze Brazilian policies and the effect on deforestation policies to verify the claim I just made. In particular, they can divide the deforestation phases in Brazil in approximately three. One was in the early 2000s or before 2005, when we saw very high deforestation rates, and it was associated with the Brazilian policies at that time to develop the Amazon. Then it was reversed, and we could see the sharpest drop in deforestation rates we have ever seen in any country when the new laws protected the Amazon rainforest in Brazil. And these laws were also enforced, proving that the government can conserve the forest if it wants. Since that time, however, we have seen a new phase, a third phase, and now again with very high deforestation, which has accelerated recently, as I mentioned. And they find that there is concrete evidence that the Brazilian state is now favoring exploitation over conservation. So because of these externalities that I mentioned, some countries, for example Norway, in particular Norway, have offered payments to Brazil to reduce deforestation, so-called REDD+ funds. These have now been halted, of course, because the deforestation has accelerated and exceeded the benchmark we agreed to, but also because there is no longer an agreement over what the funds should be a function of. In particular, Norway has argued that we should earmark the payments for conservation to conservation policies, while the Brazilian government would like to have more discretion over how those funds are to be used. So I think even though I have now said a lot about Brazil, I will talk about a very general problem, which should be interesting also for economic theorists, and that is that the government in any country who has a resource, they face the decision of whether to exploit the resource or to not exploit it. And if it's not exploited, if it's instead conserved, the next government will inherit the same dilemma. So that's a dynamic game between different governments. So when I study this, I'm interested in several questions. Of course, how is the current decision about whether to exploit or conserve depending on future policies? I'm also thinking, I'm interested in comparative static. In particular, what are the roles of stability, political stability, conflicts, and checks and balances and institutions? And I'm interested, so after studying this game between the governments, I'm also interested in how this game can be taken advantage of by stakeholders. That's important because I already mentioned Norway, who are paying for conservation. But on the other side of the market, we have the agricultural lobby who are paying for exploitation. And it's important to know how and to recognize how these stakeholders can take advantage of this dynamic game between the governments. I'm interested in the expected outcome. So the positive questions like that, but also normative questions like how should the compensation for conservation be designed and to whom should it be targeted? And I will talk about time inconsistency problem related to this.
So, Bud, I gather I'm allowed to jump in and ask questions at any point. So forgive me if I've misunderstood the rules. So it seems like there's two separate issues here. And I just want to be clear before you start. There's one issue around the time consistency and dynamic policy of exploiting a resource with political constraints. The other is that this is a global externality, so that we should care about what's going on in Brazil, even though we have no influence, direct influence over the government of Brazil. So it wouldn't be surprising that in a world where that's going on, that Brazil would not get the right level of conservation, even if there was no amount of time inconsistency. It seems to me your primary focus is on the first, but that's unlikely to give you the thing that maximizes world welfare in that world.
To some extent, of course, if you only look on a game between governments, you can learn how the externality problem is magnified by the dynamic problem between governments. Of course, we would not expect the externality to vanish in such a game. But as I mentioned, I will also talk about how stakeholders, such as the rest of the world, can intervene and take advantage of the dynamic game between the governments in order to increase conservation and therefore to induce the internalization of the externality. Yeah. Okay, so I will not say too much about the literature, but there is a lot of literature and on, for example, the dynamic games between governments. Think about the games between governments when they are making investments in state capacity, the accumulation of debt and repayments of debt, the stabilization, And there are two things which distinguishes what I will say relative to that literature. One is that in many of these papers, the decision between governments is reversible. For example, when it comes to the accumulation of debt can increase or decrease in many of these papers. While in the paper I will talk about today, the irreversibility is going to be very important. Another difference is that in those papers I mentioned on this slide, each government hopes that the next government will end the game, or that other politicians will end the game by, for example, making the investments or repaying the debt or stabilizing the economy. In the game I will present, each government hopes that the next government will not end the game, because ending the game will basically means to exploit the resource. And that difference is going to be very important. And I will say more about that in the end. It's related to several strands of literature. Let me just mention one more, and that is the one on multiple principles or lobby groups. Because I will talk about multiple principles such as the agricultural lobby, as well as those offering payments for conservation. And typical finding in this literature, for example, in Grossman and Helpman, is that if just all the stakeholders are organized and lobbying, then we should not worry. It will even each out, and it will just induce the government to take all interest into account, and the outcome will then be efficient. It's going to be inefficient in its literature if some groups are organized, but some groups are not organized. But this fundamental result is not going to hold in the dynamic game here, because it's a big difference between lobbying for an action, which is to exploit the game, which ends the game, and inaction, because you have to then lobby every period to keep on inducing the next government to conserve. So that's going to be a difference. Okay, so I think I'll go straight to the model. I will have a small break after introducing the model, so in case you have clarifying questions. The model is extremely simple. So in every period, there is a president. It's going to be, in all historical cases of interest, is a he. The president decides on S, which you can think about as the fraction of the resource that is exploited, or alternatively as the probability that the resource is depleted. It doesn't matter for the theory whether it's the fraction or the probability, but for intuition, it helps to think about it as the probability. So these thresholds or the boundaries, they do not need to be there. So you can think about this as to be any number between 0 and 1. Although I allow for this interval to be restricted because, for example, because of checks and balances, the difference between x upper bar and x under bar basically measures how much damage the president can do. Alternatively, it can represent the technology. So even if the president would like to conserve, there is a limit to how low you can reduce the probability of conservation. This probability may be reduced further now when we have monitoring technology with satellite data, for example. So it could be different now than it was before. The x upper bar is then the speed of extraction if you would like to exploit as fast as possible. So these are not going to be important for the results, but it will add some comparative statistics, which we can discuss. So the particular president I have in mind will only be a decision maker at one point in time, but we can allow the president to be associated with a political party, which is out of power with probability P in any later periods. So if P, for example, is 0, that means that you know that your party will stay in power forever. So that's a stable dictatorship, maybe. While if P is very small, that means that you are a minor party who are unlikely to have the president in the future. Of course, if you have n political parties, then the probability that you are in office at any point in time later may, in a symmetric situation, be just 1 over n, which is one possibility.
So, Bård, can I just in your world, checks and balances are always going to be used, I guess, to reduce depletion. But if you think about, say, Saudi Arabia, and maybe the people would want checks and balances to actually increase depletion because the citizens are basically maybe could benefit more from public services, a better economy, if it wasn't run by a stable ruling elite. But so it seems like it could go either way, depending on the environment, particularly if you have a stable dictatorship. You might think checks and balances are going to go in the opposite direction.
That's true. So I will actually not necessarily take a stand on this, because I think I could allow for your interpretation. If you say that checks and balances mean a small interval between x and the bar and x upper bar, this interval is smaller if, for example, x and the bar increases. And this means that even a president who would like to conserve may have less power to do so. That is also an interpretation of checks and balances in this interval, in this model, because that means that the president have less power. So I think I can twist the model to allow for checks and balances to be good if x upper bar decreases, or bad if x under bar increases. Yeah. So there is a benefit of exploiting the resource. I let this benefit per unit of deforestation be B, and I allow for the possibility that B upper bar is the benefit for the party in power, while B, simple b, is the benefit for everyone else. And there is a conflict of interest if the delta, the difference between those b's, is positive. There is also a cost of exploiting. This cost could be maybe in a different model. It could be the option value. It could also be the physical cost, the harvesting cost, the conservation value of the forest. It could be the loss of compensation from abroad, which you lose when the forest is exploited. This cost is simply C, but I would like to have some uncertainty in the model, meaning that we cannot really predict what a future policymaker will do. I can introduce uncertainty in the B's or in the C's, it doesn't matter, but let me just do it in a C. So that means that a particular president P has a conservation value C subscript P, which is uniformly distributed between C and the bar and C and the bar plus sigma, where so sigma is basically the uncertainty in the conservation value of future presidents. As I mentioned, this uncertainty could alternatively be in the benefit. It doesn't matter at all. So there's a common discount factor. So I will look for a stationary subgame perfect equilibrium. In particular, if you think about X, or this probability, this S, as the probability that you are exploiting the resource, and if you cannot observe the S part itself, but only the outcome whether the resource is exploited or not, then it's easy to see that every subgame perfect equilibrium must be stationary, because every history which allows you to continue the play is going to be identical. So now this means that suppose that X is the probability that a future government will exploit. You don't know the identity or the preferences of the future president, so X is going to be an uncertain variable, but it's going to be a constant variable, which is the same in period t+1 and t+2 and t+3 and so on, given the restriction to a stationary SPE. So suppose now that I'm the president and I decided to conserve. So this is now my conservation value in the next period. Then with probability P, I'm out of power, and with probability X, the resource is exploited, and then I get a benefit B. But with probability 1 minus P, my party is still in power, and then instead I get B upper bar. If the resource is not exploited, then I get the conservation value, and the game continues. But note that if the resource is not exploited, the game ends. I'm sorry, if the resource is exploited, the game is over. So,
sorry, Bob, can I just come back to the stationarity? I must be misunderstanding the model, because if you exploit, eventually you'll run out of the resource. So, you know, sooner or later the game's got to look non-stationary as you approach a point at which the resource is completely exhausted. That doesn't seem to be a feature of your model. So the Amazon is sort of infinitely large, isn't it, in your model? I guess I'm just not.
No, it's not infinitely large. You know, in the paper, I'm a bit more careful when I discuss the analogy to a gradual depletion of the resource. I think it simplifies things a lot if I invite you to think about the resource as one unit that is exploited with some probability X. But the reason why this is equivalent if X is a fraction is because both the cost and the benefits are linear in X. So even if the forest is basically cut in half, the game looks identical to before. So the stock is actually not payoff relevant, because both the cost and the benefits are cut in half when the size of the stock is cut in half. So therefore, the game is essentially identical, just as the cake is reduced if you are discounting it by a discount factor, for example. And of course, when the resource is 0, the game is over, because there's the benefit and the cost have vanished. But as long as the resource is there, it doesn't matter. The size of it doesn't matter, because the cost and benefits are proportional to X, and for all decisions is the cost relative to the benefit which matters, and that ratio, of course, for that ratio, the size of the stock will cancel out. But I think it's interesting to think about this, but I invite you to think about a resource now as a unit, which you deplete with some probability. It simplifies things, and it allows me to focus on other results instead. So if you look on this problem, then you can see that I will, the president today will think about whether to exploit the resource and get B upper bar, or conserve it, and then you get the conservation value C plus this continuation value V, which I just described here above. And clearly, because if I'm the president, my conservation value depends on my type, theta, there will be a threshold, right? So there will be a threshold, so that if, call this threshold theta X, because it depends on X, where X is the expected probability that the resource will be cut in any later period. And that is going to be important for me, and that is going to influence the threshold. But for any X, there will be a threshold, so that if my theta, my conservation value, is high, then I prefer the lowest possible probability of exploitation. Then I prefer to conserve. If instead my conservation value, which is reflected by this theta, is small, then I prefer to exploit, and then I exploit as fast as I can. So because of this linearity, there will be a bang bang, there will always be a corner. I either try to conserve as much as I can, or I exploit as much as I can. So this threshold is going to be important. This threshold is going to be a function of X and an increasing function of X. And intuition is quite natural. If I think that in the future, the equilibrium probability that any other government will exploit a resource is going to be high, that means that it is less beneficial for me to conserve already or today. Then I rather exploit myself in order to get the B upper bar, instead of simply the B, which I will get if my opponent will exploit the resource. So the larger is X, the larger is the set of types which prefers to exploit. Particularly if P, the probability that I'm out of power later, is high, because then this B upper bar is not going to me, but it's going to the opponent. And again, also particular if this delta, that's the difference between the B upper bar and the B, if that difference or the conflict of interest is large, because then it really is harmful if my opponent exploits the resource instead of me. So you can see that if, for example, P was 0, and I know that my party will be in power forever, then no matter when the resource is exploited, I will get B upper bar. In that case, the future X is not going to influence my decision, because at the threshold at which I am indifferent between exploiting and not exploiting, then I would also be indifferent between conservation and exploitation in any future period in which my party has power. So then in that case, the future X will be irrelevant to my decision today. It's going to be relevant only if I fear that with some chance I'm out of power and there is a conflict of interest, because then the opponent will get the benefit B upper bar instead of me.
So, but an obvious point, but maybe you should just comment on it. At the moment, P, the P is independent of X, which seems like quite a strong assumption.
Yeah, that's true. So,
I mean, of course, it's a model, and we don't do everything in every model, but you must have thought about that, because it's,
I will talk about that also. I will talk about it. So I think to some extent, I would like to see how much I can get out of this model in a simple setting, even when the probability that you're in power in the future is independent of X. So I want to check first how much I can get out of that model. But I will talk about an endogenous P later. But I think this is quite relevant, because after all, there are so many issues in politics which are determining who is going to win. And the deforestation policy is going to be one of them, but not necessarily the major issue. But I will talk about it.
I guess I don't quite buy that defense, though. If you think of Saudi Arabia today, Saudi Arabia's exploitation rate is determined by whatever it has to do to make sure that it's the same ruling elite in power tomorrow. It's the salient issue, because without the military and other resources for staying in power, there's nothing left. So
I agree.
I don't. In Norway, maybe you're right, but I don't think in many of the repressive dictatorships in the world.
That's perfectly fine.
So
here, because the decision of a party is determined by the particular president's type, you basically, in this model, you learn nothing about that party's decision in the future by observing what this party is going to do now. So in this model, the parties are, in any case, identical. You don't learn anything about them. So in this model, it's basically not an assumption. It follows. But as I promised, I will very soon actually talk about an endogenous P anyway. So I will give something for you. But it's a good question. So as I mentioned, if P or delta is 0, then the current exploitation doesn't depend on what I expect in the future. Okay, so basically my the set of types which prefers exploitation, and the probability that I am a president of that set is the same as if there was no exploitation in the future, because it doesn't depend on that X in the future. But if the P and the delta are positive, then the larger is X in the future, the more I expect next presidents to exploit, the more I will find it optimal, or the larger is the set of types who prefer exploitation today. So and then the equilibrium can be 1 of 4 times. So let me just illustrate it. So suppose so this is just a 45-degree line. Here is x. That's the probability that the current president is of a type that prefer exploitation, as a function of x, which is the probability that any future government will exploit. So suppose first that x of 0 is negative, or is less than x and the bar. So then there will be an equilibrium where no one exploits. So because if no one exploits in the future, I would never exploit, no matter what my type could be. And that's a stable equilibrium. But if there is a lot of uncertainty in what the types can be, then it's going to be the case that even that if this condition holds, then it's an equilibrium that if I believe future presidents will exploit, then I will also exploit. Because if I think that they will exploit with a very high probability, then it's better for me to exploit right away. Because then I will for sure get the benefit B upper bar and not only B. So in this case, you have multiple equilibria, you have self-enforcing equilibria. One equilibrium is that if I exploit only because I expect others to exploit, even though there is also a good equilibrium where I would not exploit if I trusted that no one else would exploit either. So if this x of 0 is positive, which amounts to this condition here, there is an equilibrium where there is no equilibrium where I will conserve with certainty. So basically, this amounts to the possibility to a situation where there is always some types, some thetas exist that are so low that there is a probability that some presidents would like to exploit no matter what, even if that president knows with certainty no one else is going to exploit in the future. It's still possible that the president can be of such a type today that he would like to exploit. If that is the case, then basically you are going to this best response function is going to be above the 45-degree line in the beginning, and one possibility is that it's always above like this. Another possibility is that this crosses. Let me discuss this first. So basically now, if it always lays above, then you can see that iteration of the best responses will lead to a unique equilibrium where everyone exploits with probability 1 or as high x upper bar. This is true even though this point could be arbitrarily small, meaning that if I know that I was in power with certainty, the probability that I'm out of power, that is 0. Then the probability that I would be of a type that prefer exploitation would be this arbitrarily small. Nevertheless, in equilibrium, I exploit with probability 1. The intuition for this is because you can see that there is some kind of a domino effect. So think about it just this way. So suppose that I think that there is a probability of 1% that the president in 50 years is going to exploit. The situation captured by this figure is the following: that if that is true, the president in year 45 will exploit with probability 2%, because it's not very likely that the president in 50 years will exploit, but it's sufficiently high that there is some types who are going to exploit also in 45 years from now. And that probability is a little bit higher than 1%. And it's even higher in 40 years from now. And it's even higher in 35 years and so on. So it will basically lead to a domino effect that a small probability that someone in the future will exploit is leading to an unraveling of the conservation's incentives, and you get the exploitations immediately. So the fourth possibility I will discuss is this possibility on the right. So this is a situation where if x is very small, that means that basically we believe that there will be conservation in the future. There is still some chance that the current president will exploit. At the same time as if x is very high, that you think that the future governments will exploit, it's still a possibility that you have a president of such a type today who prefers conservation. So this is a situation, basically, if there is a lot of uncertainty in what the types of presidents can be. You can never rule out conservation, even if the expectation about future conservation are grim. At the same time as you cannot rule out exploitation, no matter what you think about future presidents. So basically, this leads to an equilibrium with an interior solution for X, and which depends on the parameters in an intuitive way. And this is the equilibrium we're going to focus on from now on, because it's I'm already done describing the other types of equilibria, and also because this is the situation I think is more realistic if you think that there is a lot of uncertainty regarding what future policies will be. So then there will be an equilibrium, X, a fixed point, where the probability that a government will exploit is naturally higher if, for example, the benefit of exploitation when you are in government is high, while the cost of exploitation is small. But more interestingly, it depends on the P and the delta. So remember, P is the probability that I'm out of power. Delta is the loss in benefit I get if another government is exploiting the resource instead of me. If that product is high, then I will exploit with a higher probability. In fact, it's quite interesting to look to compare that X, the fixed point, to X of 0, which the probability that, or the probability that I exploit if I'm in power forever, if the probability P that there is rotation of power is 0. That ratio, the X divided by X of 0, can be written as this. And that's what I will call the multiplier, because it measures how much X changes compared to how much X of 0 would change if you have a change in parameter B or in C, for example. I will illustrate this on the next slide. But before I do that, notice this multiplier. Basically, if I go back this point, the equilibrium exploitation probability compared to how much you would exploit if there was a stable political environment with no rotation of power, that is larger if the discretion of the president is high. Which you may, in some situations, refer to as a situation where institutions are weaker, you have less checks and balances if the president has a lot of power. Or if you think that the technologies are more effective, in the sense that, for example, suppose that there's a president who can conserve, can exploit, and he can do it very fast. So suppose that you have more machinery and you have a bigger industry who can exploit and make deforestation happen at a faster rate. What is going to happen is, of course, is that the set of presidents who prefer exploitation, they will exploit at a faster rate. But in addition, it's going to affect the cutoff, the set of presidents who prefer exploitation. Because if I'm almost indifferent between conservation and exploitation, when I know that whenever a future president prefers exploitation, he's going to exploit very rapidly, that reduces my value of conservation today. And therefore, if I'm on a margin, I would rather exploit. And in equilibrium, a smaller set of presidents would prefer to conserve. So that's why you have a multiplier effect. And I can illustrate in this diagram. So what is going to happen, for example, if say, suppose that, so in this situation, suppose that the conservation value increases. So if you fix X, that will lead to a smaller probability of exploitation, because the set of types who prefer to conserve is higher if C and the bar increases, because that's the conservation value on average, or for the common component to the conservation value. But what you can see here is that you can see that the equilibrium effect on X is going to be much larger than if you had hold X constant. Because when the conservation value increases, for example, because of the compensation for conservation from UK or Norway, then I know that future governments is going to conserve with a higher probability. And that increases my incentive and benefit from conservation already now. And that indirect effect comes at the top of the fact that I would prefer to conserve even for a fixed X. So that's why we will have it can have a much larger effect on X when the increase in the conservation value is going to take place not only for me, but for every president in the future. For example, because we are expecting payments for conservation. So let me say a little bit about heterogeneous party. This is almost like a discussion because I will not say a lot more about it later, but since you had questions about it. So it's easy here to allow for multiple.
But can I just come back?
Okay.
Just to think, so perhaps making the mistake of trying to relate back your model to the discussion of Brazil at the beginning. And
that's fine. No, this
as I understand, yeah, which may be a mistake because a model is, I don't know whether you really think the model can explain what's going on in Brazil or not. But am I to think that, so it looks like things have changed with Bolsonaro. But in your model, everything's in steady state. So if it changes for Bolsonaro, you have to sort of believe everything is changing for the infinite future because everything's stationary. So I'm kind of trying hard to map back what you think, say, has been going on in Brazil with the acceleration of the deforestation back to your model, if at all, or just you can tell me, well, your model's not really able to do that. But can you help a little bit on how the story of what you think is going on?
Yeah, I can
has
do it
some link back.
I will do it now. So I will do it on this slide. And as a motivation for that, it's easy to see how the model can allow for heterogeneous parties, which can be interpreted as, for example, having different probabilities of staying in power or being out of power. Suppose, for example, you have two parties. Then you can have one basically threshold for I and one threshold for J. And it's easy to see that the minor party is more likely to exploit in this model because it's more likely to be out of power later and therefore to not be able to enjoy the particular great benefit you get if your party is the one exploiting the resource. So of course, then you can see that, okay, so this means that a minor party is more likely to exploit the resource. And it's easy to see that if you have voters in this model and they prefer conservation because after all, X is going to be bigger than the X of 0 in equilibrium here. So it's so the voters who only get the benefit B, for example, from conservation, from exploitation, they prefer X to be smaller than the parties. Suppose that is the case, then you can see that when the voters understand that the minor party is more likely to exploit, they are less likely to vote for the minor party, reinforcing the fact that it is a minor party. So you can have multiple equilibria here, where a minor party is small, because it's expected to exploit, and it's going to be exploit because it's less likely to be in power later. So of course, now the minor party is going to be anticipating that it's actually handicapped in the election because of the existence of the resource. It's the fact that voters think that they will exploit faster, that they are going to be re-elected with a small probability. So this, of course, means that the minor party has an incentive to end this game, which is handicapping them in the election in order to get even in the future. So in this model, then, the minor party has an additional incentive to exploit very fast to remove its handicap. So if I want to say something about Bolsonaro, it could be that, for example, he was a surprise winner. He was coming from a party who had very few seats. in the election, and he has not yet declared any intention that he would like to stay in power later. So he has instead said that he would rather be a good president for 4 years than a bad president in 8 years. So this may be a situation where, according to this model, his party will have a strong incentive to exploit very fast. So I do think that the model can say something about Brazil, particularly when I twist the model to allow for heterogeneous party, as I just did now. However, now I want to get back to the basic model with homogeneous, where I don't learn anything about the party over time, in order to say something about how to introduce the stakeholders.
Okay, so I don't want to get hung up on this, but I think there's you're thinking about this as parties, but when we think of presidential systems, we think of individual presidential careers. So, the fact that Bolsonaro is a short-lived president now says nothing about the future of anybody representing his party. It's down to individuals, like saying with Trump or whoever. Yeah. So I take the point that you're trying to kind of relate that, but it's the part of the model that says this has to be sort of therefore projected forward, that there will always be these kinds of short-lived presidents. Maybe there's a way to think about it as there's two, rather than thinking about it as parties, there's sort of two kinds of presidents, short-termists and long-termist presidents, and that somehow they randomly come to power. I don't think when you're talking about presidential systems in general, parties are the way to really think about that. That would be more natural in a parliamentary system.
Yeah, thanks. So, of course, this I think instead of having short-term, long-term presidents, I'm not convinced that I alternatively just cannot simply capture the intuition you have by this theta, because the theta, after all, maps into a probability that you would like to exploit or conserve, and this equilibrium, which I'm now focusing on, where we have this interior x, is the equilibrium you get if you can never be quite sure about what type of president you will have in the future. That in the sense that there will always be some chance that some president in the future will exploit. You can never rule it out, even if that president expected future conservation with almost certainty. Such a type will exist that exploits the resource. So that is when you have enough uncertainty of this kind, that is when the equilibrium, the x is a fixed point between x and the bar and x at bar. So I think I would still like to argue that I can capture this intuition you have in mind, and also the situation in Brazil, for example, by this small observation I have it at the end here. So now, and that's important because of course the model is going to be normative in part when I proceed from now on, but to have any trust in that normative lessons, it's important to have observations that fit the basics of the model, and this is to some extent the stage in my presentation where I say that okay, so the basic model is not inconsistent with some of these observations we do. So let me now see what it can say about, for example, payments for conservation. So I'm running out of time. So let me suggest the following, that I just talk for the remaining, is it 12 minutes? And then we have time for questions, okay? I think that's correct, yeah. Maximize the probability that I will say it all. Okay, so one type of stakeholder could be the agricultural lobby, who may benefit from A once the resource is exploited, and A can then be present discounted value of having access to the land. If in return the A offers L, the lobby contribution L, conditional on exploitation, the continuation value of A would be that with property X, there you have exploitation, you get A, but you have to pay the lobby promise that you made. And with property 1 minus X, you don't get this A and you don't necessarily pay, but the game continues. You can hope that you get the A in the future. So, of course, now, if again, expectation about future policies are going to be important, because now, if the president today expects that A will influence also future policymakers, meaning that they will be more likely to exploit, then the point of conservation today is diminished. And the current president is more likely to exploit even with no payment at all, or is willing to exploit with a smaller payment once we expect that also future presidents are going to be persuaded to exploit, simply because the benefit of conservation is then diminished. So this means that the rate of return to lobbying can be extremely high if the presidents expect these lobby contributions to be present also in later periods. So this means that the lobby group would can definitely benefit from this multiplier effect, and it would therefore like to choose a lobby contribution, L star, which is larger if you can commit to future L than if you cannot commit to future L. Of course, this means that if you can make it credible that in the future you're going to lobby, you would like to announce that they're going to lobby a lot, because then the current presidents understands that quite likely later presidents are going to exploit, and then the current president will exploit with a higher probability. Of course, once the next period comes, the lobby group may want to reduce the L compared to what it had promised. So the Markov perfect L, if you cannot make a commitment, is going to be smaller, but smaller than if you could commit. So that's to some extent a timing consistency problem for the lobby group. It would like to, but in whether you can commit or not, the presence of those lobby contributions in the future are going to be very helpful for the agricultural lobby right now. So I can introduce the Norway in a symmetric way. So now Norway, or the donor, she is a long-lived player who will get a damaged D if you get exploitation, or you get this D avoided as long as you get have conservation. So that would mean that suppose that you can pay K conditional on conservation. That means that the continuation value for the donor is 0 if the resource is exploited, but if the resource is conserved, you avoid the damaged D, you have to pay the compensation, and the game continues. So just as before, just similar to before, the donor can take advantage of the multiplier effect, because the larger is the expected compensation in the future, the K star, the more likely the president is to conserve already now, even without any payment at all, or it's willing to conserve today at a smaller cost, if it's expected that also future presidents are likely to conserve because of these compensations. So to best take advantage of this effect, the donor would like to commit to an X star, which is larger than what it will find to be the equilibrium value in a Markov perfect equilibrium in which you cannot commit to future payments, just as for the lobby group. So there is a timing consistency problem where the donor would benefit from delivering high compensations in every future period. But you really need to build a reputation or have some commitment device to really fully exploit this multiplier. It's also interesting to note that the compensation is increasing in the multiplier in this P and delta. So, and I could show you that in the figure, because if the multiplier is high, that means that you remember that X is a function of X, XT today is a function of X, which is upward sloping, and the bigger is the multiplier, the steeper it is, meaning that the fixed point, when it crosses the 45-degree line, is going to be more sensitive to changes in the parameters, for example, to a change in the compensation value. So the bigger is the multiplier, the bigger is the effect of future payments on today's decision. And to really take advantage of this effect, you would then like to commit or to promise a higher X a higher compensation in return for conservation. Okay, so it's also easy to have it all together. So one effect, of course, is that the lobby contribution reverses the effect of compensation of the compensations for conservation. So it reduces how much conservation you get for every level of K. At the same time as the optimal K will increase in L, because it increases the multiplier. Because basically the L, the lobby contribution to the presidents will increase the conflict between the current presidents and opponent in the future. Because now the current presidents understands that the later presidents may exploit because of the benefit of the lobby, but that lobby will benefit that president and not yourself. So the conflict of interest increases, and this means that the multiplier effect will also increase, and therefore the effect of how changes in future parameters affect the fixed point X today. And because of this, again, once again, the optimal K compensation will increase. But the problem, a problem is that the lobbying in this simple model, at least, where the lobby is basically conditional on exploitation, the lobby group has an advantage because it only needs to pay once at most. But the donor would have to pay every period as long as the game is continuing. So it's therefore easy to see that you are disadvantaged if you would like to pay for conservation in this game. One way of seeing this in a simple setting is that suppose that A and D, that's the stakes for the agricultural lobby, and this is for the donor. Suppose that the conservation value is higher in the long run. So because D divided by 1 minus delta is larger than A. Suppose that is the case. So it's basically when you add these two stakeholders in the game, the case for conservation increases. At the same time, I suppose that the period, the A in one is larger than D. So that means that if you increase both of them, then optimally, when the both an A and D's are sufficiently large, the D minus divided by 1 minus delta is larger than A, so then you should conserve. However, in equilibrium, the payments from the agricultural lobby is going to be proportional to A, and the payment from the donor is going to be proportional to D. So eventually, these payments are going to be compensating the president for exploitation more than for conservation, and you will then get exploitation with certainty, or with probability X up the bar. So this is very inefficient because of this asymmetry in paying for action versus inaction that I mentioned. So one problem here is that the presidents today will not really value compensation to future presidents. However, that is a problem which can be endogenous, right? Because as I mentioned in the beginning, there's a debate how the payments should be structured. And you can imagine that maybe K, the compensation payments, could be earmarked for example, public goods. That would benefit the president, even if the president is out of power in the later. Of course, a payment for public good is maybe having a lower effect on the president in period T, in this particular period, because the president will not have full discretion about what to do with the payments. On the other hand, the current president understands that if it conserves, then in the future, the payments is going to something which will benefit that president, whether or not his party is in or out of power. And therefore, that can increase the conservation value. So basically, if delta is the importance of the future, the discount, then if that is high, the donor is better off earmarking the funds for a public good, which benefits the president in the future, even if the president is then out of power. As an intermediate case, you could think about a situation where the donor would like to give the party a discretion about how to spend the money, not necessarily the president individually. This, if P is small, that is the probability that you are out of power later is small. That can be more efficient because then the president today understands that it will quite likely be one of those who benefit from the compensations in the future. So another problem, however, is that the donor must pay every future president to give up on their unique possibility to exploit the resource, which can be very costly. So in this model, it's tempting to ask the question about what about paying A, the agricultural lobby? And this is not an unrealistic question, because one of the discussions about the RED plus funds is that maybe they should be benefit the farmers to a larger extent, and not because currently the farmers are not seeing to benefit a lot from the compensations. In this simple model, suppose that you pay the agricultural lobby, and in order to reduce their incentives to lobby. For these extensions, it's maybe natural to compare the how long-lived A is compared to how long-lived the president is. So suppose now that the agricultural lobby loses power with probability Q. Remember that the president lost power with probability P. Now, if Q is small, and P is large, that means that the agricultural lobby is more likely to be a long-lived player relative to the Bolsonaro. Then it's better for the donor to pay the agricultural lobby to not lobby, basically, to reduce its incentive to lobby for exploitation, instead of paying Bolsonaro. So I could talk about delta negative, because that could capture many other scenarios. Maybe yes, I'm going to conclude.
Yeah, thank you very much.
Yes, I will therefore not do it. But interestingly, this can lead to many results, which can basically reverse the effects I have mentioned. So if to wrap up, a small probability of future exploitation has a multiplicative effect on exploitation now, especially if the president is powerful now, but unlikely to have power later. And the return to lobbying and also payments for conservations can be very high, especially if the future payments are also credible. But there is an asymmetry between paying once to get exploitation versus always in order to get conservation. And this asymmetry implies that the resource is more likely to be exploited with these external stakeholders. But the donor may benefit from earmarks to public goods or to the party, particularly if the president is unlikely to stay in power, and therefore it's important that the president will nevertheless get a benefit for future compensations. Or you can benefit from paying the lobby group if the lobby group is more long-lived player than is the party. The timing consistency problem here include that the donor will be tempted to pay less than it would like to build a reputation for. And it's also tempted to pay the president directly because it has a bigger effect right now, even though the donor may want to build a reputation for these earmarks to the public good. Okay, so I think I will stop there and take questions.
Thank you very much. It was an excellent talk, and thanks to Tim for also great comments. We're going to move to a Q&A session now, but I think we should start with Tim. Tim, do you have any further or final comments or questions?
I guess there's a sort of slightly philosophical comment. I think it's a bit more than that. As you pointed out, the results all flip around when you flip the sign of delta. Yeah. So which results should I be paying attention to? Or in some ways, a model can be too general because it can give you results for all scenarios, but then you really want to know which of the results are the ones that you should care about, rather than in the space of all possible results. So perhaps you could just be a little clearer to us which of the results you really want us to pay attention to.
Good, thanks. I think I would not mind if you really pay attention to the difference between delta positive and delta negative, because instead I could, for example, one result which holds in either scenario is that the importance of expected future policies are going to be super important. Also regarding how you should design payments if you are one of the stakeholders trying to influence the outcome. But to be more detailed, I think that it's important to recognize whether this is a game where each policymaker would like the next policymaker to end the game, for example, by repaying the debt or investing in state capacity, or if instead this is a game between the governments where each government hopes that the next government will not end the game because it means exploiting the resource the current president alternatively would prefer to exploit itself. And that has whether the disagreement goes one way or the other is very important. For example, regarding whether the donor would like to build a reputation for paying a lot or paying little. Because if you have, for example, this why stabilization delayed game, then each government is more likely to stabilize the economy and to pay that cost if it thinks that later governments will not do it. So for the donor, and for example, the IMF would now then like to build a reputation for not helping out with this bailout. Because if the current president thinks that it's unlikely to get that future governments will get the bailout to do the stabilization, then it's more likely that the current government does it now. So which is the complete opposite of what I've said. And I think that's an important lesson in itself, that you have to recognize what type of game you are in when you are deciding on what is the optimal compensation scheme. Okay.
Okay. We have a few questions in the Q&A window here. Can we ask Neha Dopa to unmute and ask?
Thank you. Thank you, Bart. That was super interesting presentation. I just had just a question on one of the scenarios that you presented, where you said that a baseline case where if there's no presidential rotation. So I was wondering if that kind of reflects a monopolist exploiting a natural resource. Is that case kind of similar to that? Would I be expecting results like that?
Yes. So to some extent, the effect of positive P, that is a rotation of power, it reminds us a little bit about a common pool problem, right? Because it's a common pool between alternative parties or presidents, and the more likely that you are the one who has a monopoly on power, mm-hmm. The more you have solved the common pool problem, because you are in control of the resource, and then you will exploit. You're more likely to conserve in this game. So I think this resonates also with other results in many other parts of economics, right? So if you, for example, if you have a monopoly, you are producing less. If you are a monopoly exploiting a depletable resource, you are also depleting it slower, for example.
Yeah. Okay, thank you.
Okay, we have a next question from Rahul.
Hi, Bart. Nice talk. So I just had this question regarding thinking about ideological polarization in terms of like the politicians, because you mentioned the case of Brazil, and there seems to be this clear case of a right versus left ideological divide, and whether that could be incorporated in the model. The other part of the question that that kind of struck me was whether there is some kind of persistence. Like once you start exploiting, maybe there is some kind of irreversibility in the decision, and it makes it much harder. Is there something that?
Good, thanks.
Persistence important.
Thanks. I think actually the second question is more easy, at least in the extreme. So suppose that you have, if you could take it to the extreme, suppose that X is a once and for all decision because it leads to a path dependence that is very difficult to move away from. So basically this means leads, if I go back to the figure I had at the beginning, this leads to an X of 0, because then basically I'm taking the decision on behalf of everyone, and I will not be worried about how later presidents are going to change that decision. That X of 0 is going to be a little bit different, because now I know that if I exploit in order to get the benefit of the resource, this will lead also my opponents to exploit with a higher probability, and therefore that some of that benefit will go to them and not me. So then I will reduce it exactly as in this figure for another reason, which happened for another reason. So then it will go down, and you will definitely get more conservation because of this path dependence, if I call it that. Particularly if that is extreme. About heterogeneous parties, so I didn't mention it, but it's easy here to allow for parties who have not only different probabilities of staying in power, but also different benefits and costs. And it could be also, it can also be the situations where if the benefit of exploiting for a particular party, say Bolsonaro, is very, very high, it can also mean that that party would prefer its benefits so much from not only from exploiting itself, but also no matter who would exploit, that it prefers other parties also to exploit the resource later. In that case, the benefit would be downward, the best response function would be downward sloping and not upward sloping like this. And it would be a little bit more similar to the alternative literature that I mentioned, because then in this case, Bolsonaro would hope also, to the extent it cannot deplete the resource himself, he will prefer also later presidents to deplete the resource in order to get agricultural expansion, for example. So then the game is that the one with the delta negative, which I mentioned, it's similar, even if now delta can be positive, but it's going to be negative. The multiplier effect will basically be less than 1, meaning that if Bolsonaro thinks that future presidents are going to conserve, then the model as have so far, that may lead to an increased incentive to conserve, because it will have a long-lasting effect. But for Bolsonaro, it can be quite the opposite, because if later presidents are not going to exploit resource, then definitely he will do it himself. So this possibility can be taken into account and effect in the model by changing its parameters. But when the best response function is downward sloping, it will definitely alter some of the results.
Okay, thank you. Thanks for
that. We will continue the question and answer session, but for those of you who have to go 5:15, let me thank you for your attendance. Thank you, Bart.
Thank you.
Thank you, team, for guest paneling. And the next question is Francesco Squintani.
Hi, Bart. Great talk as usual. Great to see you. It's again a question on heterogeneous parties, I'm afraid. So in the model, do you account for the fact that if a party, let's say with high benefits, is in power and it loses the election, then it's likely to be replaced by a party with low benefits for exploitation? Or do you search for a stationary equilibrium with independent recognition probabilities? How does this? Because I think an important feature of this stuff is the fact that who you have in power generates a reaction from people with very different ideologies. So if you have someone like Bolsonaro in power, this is the moment in which the donor really tries to do anything to make sure that not too much damage is done.
Yeah.
In the hope someone else goes up. Relatedly, when you talk about financing the party, does this change the probability that the incumbent stays in power? Is that what you have in mind?
Thanks. These are all very interesting questions. So let's see. Yes. So because I'm sure all this belongs to a separate paper, because one can say so many interesting things about this. For example, let me say a couple of points, even though, yeah, so one thing is that in this game, paying, if both the best response function are upward sloping, basically, the model I have described so far, if you are building a reputation for paying the left party, then as long as the left party is more likely to conserve, the right party will also conserve more likely, because they trust that if they decide to conserve, it's going to be conserved rather than exploited by the next party, because of this connection with the donor, even if that party, the right party, doesn't have this connection himself. But as I mentioned, it's possible to have so large heterogeneity that, for example, the right party prefer exploitation no matter who is in power. And in that case, for example, Bolsonaro, and in that case, compensations can have the opposite effect of the intended effect, because if the Bolsonaro understands that next governments are going to conserve because of the payment from Norway, then it will have an even larger incentive to take the opportunity now to exploit very fast. So in that case, it can have a counterproductive effect. But if in the donor, for say Norway, instead paid Bolsonaro, then the left party will trust that even if a crazy guy comes in offer in office in the future, that crazy party will nevertheless be paid to conserve. So then the left party will be also more likely to conserve today and to do a bigger increase the effort to conserve, even if you don't pay the left party itself. So in that, based on this logic, you can see that paying the right party, or the party who is more likely to exploit, can have a bigger effect and a positive effect on both parties than in contrast, if you pay the left-wing party only, that can have a negative effect when the right-wing party is in power. So that's maybe this was not completely answer to your question, but at least it opens, your questions kind of open up a large set of possibilities, which are extremely interesting to investigate further.
Okay, next question, Angel.
So yeah, thank you. So I mean, I understand that you conduct a very interesting analysis based on this multiplier effect. Okay, I mean, and logically, I mean, the story makes a lot of sense, but I guess that something that I miss is at least to have some direct evidence of the existence of the multiplier effect in reality. And I wonder how, I mean, I understand that your example with Bolsonaro gives some indirect support, but I wonder whether we could, I mean, another element or another prediction of your model is that the multiplier effect, if it exists, should imply a problem of tight consistency in the policies of lobbies and donors. And I wonder whether you can use that problem and the evidence of existence of this problem to give support to your theory.
Yes, a good point. Yeah, that's a good point. Great point, and thanks for not asking a question, because I would have to think more about how to use those evidence to support the predictions. But in principle, it's definitely possible, and I think that one piece of evidence for this should be that donors are trying to put in effort, basically establishing a reputation for future payments instead of just letting it go and being satisfied with the Markov equilibrium, for example.
Thank you.
Okay, Christian, you made it to the talk, so the floor is yours.
I made it, but I came 5 minutes late, so I apologize if this was discussed in the beginning. But I was wondering, in Austria, part of the national parks, for instance, are owned by the Alpine Club or the World Wildlife Fund. So I was wondering if maybe you can view this as a solution to this problem, or in other words, if you could extend the model and see when is it better that, say, the donor donates to institutions like the ones that I mentioned.
Yeah. I agree that this can be viewed as a solution to a problem, because a problem here is that the current party in power fears that even if it tries to conserve, later parties will exploit. That's kind of a fundamental problem, which leads to exploitation at a rapid rate in this model. And as I mentioned, the X can be as a fraction, doesn't need to be a probability.
Yes.
So a way out of this is clearly to kind of to tie the hands completely, to reduce. If you are the current president and you would like to conserve, if you can reduce the later president's possibilities to exploit by, for example, giving the responsibility to the WWF or a donor, then you have an increased incentive to conserve. Another way of doing this, which I'm about to investigate now with Kjetil Soltvedt, is that instead of assuming that these payments must necessarily be positive, it's possible, in principle, to give the country a loan, which has to be repaid, but you can structure the loan in such a way that the interest rate and the repayment requirements are going to be very small, say 0, as long as the forest cover is about some threshold. So this means that the current president will get the loan, and the future opponents will have a very small possibility to exploit unless they are willing to repay the loan. So this is also another way of basically tying the hands of future governments, and in particular, if the conflict of interest between the parties are big, then the current president is definitely willing to tie the hands of future presidents in this way, and therefore to accept a loan in this way. So I think that's an alternative to what you are suggesting. But both ways of tying the hands of future governments are things that the current government benefits from. Thanks.
All right, thank you very much. I think we ran out of questions and time, so I think we'll stop recording, and that's the end of the official part. But we can continue talking if we want.